So we know that matter, and we'll talk about this in another subject, we know that matter can exist as solid, liquids, and gases. But in this particular topic, where we're talking about separation, we're talking about how can we separate solids and how can we separate liquids. And it also means how can we separate solids from liquids, solids from solids, and maybe some liquids from liquids. But we won't worry about the gases because that's a little more difficult right now. We'll just focus on separating solids and liquids, solids and solids, liquids and liquids, and see how we go from there. And I just wanted to practice again, if we can, on the English. I want to hear everybody say solids. Everybody say solids. So when I say 1, 2, 3, I'd like to hear everyone say solids. Duh, duh, duh. Listen to me carefully. Solids. Solids. Nung Song Sam?
Solid.
Okay. The other key word was solids. Liquids. 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 Remember, it sounds like liquids. Quids. Ready? Nung Song Sam?
Liquids.
Liquids.
So we looked at solid, liquids, and gases, solid liquids, and we were looking at how matter is made. Because yes, we can separate solids from solids. Yes, we can separate solids from liquids. And yes, we can separate liquids from liquids. But we need to know what it means for us when we talk about separating substances, when we talk about separating different kinds of matter. And we said that matter is made up of maybe 3 different types. There's actually more, but 3 different types. And we said the basic matter, the first kind of matter, or the first kind of thing we can sometimes separate are elements. Elements. Nung Song Sam?
Elements.
Elements. Elements. Listen carefully. Elements. Elements. Nung Song Sam?
Element.
Very good. Now, can anybody remember what is an element? Can we say what an element is? Anyone remember? What is an element? Anybody? Where can I find elements? What was that big table?
Everywhere.
Say again, Azim?
Table.
Yeah, it is. We could find the elements in the periodic table, and elements are basically the first type of thing we ever look at, elements. So how can we separate elements? So here's an example of our elements. It's a pure substance, and elements cannot be separated into anything else. So when I look, for example, at just hydrogen, when I look at hydrogen, or I look at helium, or lithium, or beryllium, or boron, or carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, etc., etc., when I look at any of these compounds, if I want to try and break them down into something else, I cannot, because these are elements. They cannot be separated. They cannot be broken down. They cannot be moved apart into something else. Hydrogen is just hydrogen. Hydrogen is just hydrogen. But remember, and we'll talk about this in a moment, when I mix hydrogen, say, with oxygen, I could make water. So I can bring element of hydrogen and I can bring an element of oxygen together to make a compound. So I can take elements, 1, 2, 3 or more, bring them together, and I can make compounds. I can make new and different types of matter called compounds. I can take maybe any of those elements, put them together, and make a new compound. But that means I can often, not always, often separate some of those compounds, particularly if they're only held together physically, if they're just physically held together. And so elements of pure substance, and we can't separate them back to anything else. So all of these going forward in science, remember, are pure elements and we can't separate them into anything else. So what is a compound? Well, we just talked about that a little bit. We said compounds are a combination of two or more elements. So here's an example. Substances, compounds are substances composed of two or more different elements joined by chemical bonds. Joined by chemical bonds. So what does that mean? What does it mean? It means if I take, for example, hydrogen, and I take, for example, oxygen, and I put them together, I can make water. Now, what's holding these together are the lines or the links between hydrogen and oxygen. And luckily, these bonds, as they're called, are quite strong, and they hold them together. They hold them together. If I take sodium, for example, and chlorine, and I put those two elements together, I can make a compound of sodium chloride, which is salt. My PowerPoint's running. If I take, for example, carbon and oxygen, and I put those two elements together, I can make carbon dioxide. Now, usually, I can separate those as well. Now, I can't separate them physically, but I can separate them chemically. I can reverse them coming together. So if I wanted to, there are ways I can separate hydrogen and the oxygen back to those two elements. There are ways in which I can separate the sodium and the chloride back to those two elements. And there are ways in which I can separate the carbon and the oxygen back to those two elements. But I can't separate them physically. That means when I say physically, I can't hold water and I can't pull the oxygen away and I can't pull the hydrogen away. I can separate them chemically, but that's a different process. Same with salt. If I look at my sodium chloride, I can separate the salt, but I can't do it physically. I can't take a piece of salt and I can't take the two elements of sodium and chloride and pull them apart with my fingers or with tweezers or with something even smaller. I can't pull them apart. I can't separate them. What I could do, if I wanted to though, is if I had a mixture of water and if I had a mixture of salt, I can separate those two physically because they don't go together to make something else. Sodium chloride or salt will only go into the water. But we'll come to that in a moment. So substances composed of two or more different elements are joined by chemical bonds, chemistry. And they come together in a different way. But they can only be separated by other chemicals, not by physical means. But I can separate the compounds, and we'll come to that in a moment. So here's an example of water. For example, water, carbon dioxide, methane, and ammonia. All of those are chemically together. All of those are chemically together, and I can't separate them physically. So when I take sodium and chloride, as we just said, we can make salt. And we discussed this last time. So what are mixtures? So mixtures are when we have a combination of two or more different substances that are not combined chemically. So let me say that again. What are mixtures? So for example, water is made of hydrogen and oxygen, but that is not a mixture. It's a compound. Sodium and chloride are made of two different elements, but that is not a mixture. It's a compound. So I can't separate, as we said, water, and I can't separate sodium chloride by themselves. But if I mix those two compounds, water and salt, and I put them in some solution and mix them together, I can separate those two compounds. I can separate them. And I can do it physically. We'll talk about that in a moment. Now, one word we did practice when we were looking at these mixtures was combination, combination. And I want everybody to practice this word combination, combination. So I'd like to hear everybody say the word combination. Nung Song Sam.
Combination.
That means you two, Grace, you two, Jean, Tao Kun, Pit, Boitoy, Pry, Baimon, everybody please. I want to hear everybody saying it. Combination. Nung Song Sam.
Combination.
Tada, Tara, Ing,
Combination.
Omsin, Ion, Cartoon. I want to hear you all too, please. Nana, you also. Ready? Nung Song Sam.
Combination.
Thank you very much for joining in. Combination. So remember, a mixture is a combination. By the way, Pasatai, how do I say this in Thai? Pasatai, Nung Song Sam? Okay, thank you. So remember, a mixture is a combination of substances that are not chemically combined. They're not chemically combined. They're just physically together. They're just physically together. So water is chemically combined, salt is chemically combined. There are many substances which are chemically combined. Carbon dioxide is chemically combined. But if I mix salt with water, if I mix oxygen and carbon dioxide, I can separate those two if I want to. They're gases, but I can separate them because they don't come together chemically. They are only physically together. Okay. And a good example of that is when I talk about mixtures, think of a salad. A salad is something that has different bits. It's called a salad, but it has tomato, lettuce, onion, whatever. And I can separate those, and I can usually separate them using my hands, which is very easy. Okay, so we watched a video about the different types, and we did that with, and then we said there were two different kind of mixtures. There are two different kind of mixtures. For example, we said there was homogeneous, which is where you can't see that there are two things together. We can't see the two separate things that are coming together. And an example would be salt water. If I put salt in some water, the salt mixes very well with the water, and I can't see it. So that will be described as homogeneous. Homogeneous. But for example, if I mixed sand and water and oil, for example, I can certainly, even if I shake it up quite a lot, I can see that the oil will separate out, the water will separate from the oil, and the sand will mostly sink to the bottom. And even though I've mixed them all up, I can see there are different parts of that mixture. And that is called heterogeneous. Heterogeneous. And if I remember correctly, we were practicing the word homogeneous and the word heterogeneous. Homogeneous and heterogeneous. So again, I'm going to ask you to practice one more time the word hetero. Now listen carefully. Listen carefully. Hetero, heterogeneous, heterogeneous. Nung Song Sam?
Heterogeneous.
Very good, Pramuk. I heard that too. Okay, so let's have a look at the next word. The next word was homogeneous. Homogeneous. So I'd like to hear everybody say that if I can. Listen carefully. Homogeneous. Homogeneous. Nung Song Sam?
Homogeneous.
Okay, so let's remember, homo means it mixes very well. All, it looks like one. It looks like one. Hetero, I can see the different parts of the solution. Hetero, so here you can see the het, you can see all the different parts, but homo, it looks like one. Even though I have lemon in water, I know there's lemon inside the water, but it looks like one thing, but it's actually not. It's two things mixed together. That's a heterogeneous mixture, and a homogeneous mixture. Okay, so homogeneous, we can look at salt and water, as we said last time. Looks like it's one thing, and that's mostly because the salt is moving everywhere inside the liquid. The salt is moving everywhere inside the water. So it looks like it's homogeneous. It looks like it's one thing. Water and sand, well, that is not, the sand does not go everywhere. Sure, some bits of sand will still be floating around in the water, but most of it has gone to the bottom. So that would be heterogeneous, and that's a good example of heterogeneous solutions. Okay, so what have we been talking about? What have we been talking? We've been talking about different separating techniques, different separation methods. And we're going to talk about how to make these heterogeneous mixtures and these homogeneous mixtures separate. We're going to separate them. How can we separate them? How could I separate salt from water? How could I separate, for example, metal from sand? How could I separate, for example, oil from water? How can I separate all of those different things? There are different separating techniques. There are different separating methods. The first one is separating a mixture of solids. Separating a mixture of solids. Can anybody on the call give me an example of a mixture of solids? Anyone tell me a mixture of solids? What would be two solids that I could put together that would be a mixture? Anyone? Azim, can you think of two solids that you can put together that will be a mixture? Anything.
Sand and flour.
Sand and flour. Yes, sand and flour. If I get sand,
Flour.
yeah, sand and flour. If I get sand and flour, I put them together. They're two solids together, and I can mix them up. Gun, can you think of two solids that I could put together to mix up, to make a mixture, a solids mixture? Anything.
Wood and sand.
Excellent. Wood and sand. Very, very good. Excellent. Focus. Can you think of two solid things that I can make a mixture out of? We've had wood and sand. We've had sand and flour. Can you think of any two other solids I could mix together to make a mixture? Kubing, what about you? Can you tell me two solid things you might put together? Can be anything. Let's name two solids that we could make a mixture of. Anything at all. We've had wood, sand, we've had flour, sand. What about you? Do you think of any two solids? Anything at all?
Flour.
Rocks and flour, yes. I mean, it's a big mixture, but yes, if I get lots of rocks and lots of flour, I can mix them up and put them together. That would be a good example of that. Okay, so we're going to look at how can we separate mixtures of solids. The next thing we're going to look at is how could we separate by magnets. Magnets. Pasatai, magnet, chmai? Magnet. How could we separate something using magnets? How can we separate something using magnets? For example, if I was to mix flour and iron, I would use a magnet. If I wanted to separate, for example, sand and iron, I would use a magnet. That might help me. And the next part we're going to look at is separating insoluble solids. Insoluble. Now look at this word in red. Look at this word in red. Insoluble. That means it doesn't mix with the water. It doesn't mix with the water. So I'm trying to think of something I can put in water that does not dissolve in the water. Who can give me an example of something I can put in water but doesn't mix with the water? Anything?
Oil.
Sorry, who's saying that?
Oil.
Takun, oil and water, yeah? Oil and water,
Yes.
you're right. Oil and water does not mix very well. So oil is insoluble. Listen to me. Insoluble. Nung Song Sam?
Insoluble.
I'd like everybody to try, please. Everybody on the call to try. Listen carefully to watch my lips. Insoluble. Insoluble. Nung Song Sam?
Insoluble.
Much better. Very good. Insoluble. Now, insoluble means it won't go into the water. It doesn't just have to be water. There are other solutions with alcohol and many other things, but it means it does not mix very well. It is insoluble. Okay. So we got separating insoluble solids from liquids. How can we separate insoluble solids from liquids? Well, the first way of separating mixture of solids is hand picking. Hand picking. Now, what does that mean? Hand picking just means literally you take your hand and you pick it out. You take your hand and you pick it out. So, for example, when you go to 7-Eleven and you buy M&Ms, and if you just like the green ones, or if you're like me, if you like the brown ones, you separate the brown ones and you eat those first. Hand picking. Hand picking. Nung Song Sam?
Hand picking.
Okay. Okay, so that's the first one, hand picking. So that's for separating solids from a solid, hand picking. The next one is going to be, I've shown you actually, hand picking. Mixtures, that's when we separate, for example, in my case, when I want to separate all the reds and the browns and the yellows and the blues and the purples, M&Ms, because I like the nice brown M&Ms, yummy, yummy, yummy. So here on the left side, inside is the mixture, and here's the separated colors. The next one is sifting. Sifting. Listen carefully. Sifting. Sift. Sifting. Sifting. I'd like everybody to say sifting. Nung Song Sam?
Sifting.
Very good. Sifting. Now, what is sifting? Sifting is when you've got big parts and you want to separate out the little parts. So you've got big pieces of material and you want to separate them into small. So, for example, here we have some big rocks mixed with sand, and this sieve is shaking. We shake it out, and all the sand will come to the bottom. That is called sifting. Sifting. Good pronunciation. Well done, everybody. Okay. The next one, as we said, is magnet. Now, I know that in Pasatay you want to say maglet, glet, but no, Pasa Angrit, we want to say magnets. Magnets. Nets. Nung Song Sam? Very good. Nice shampoo. I like that. Very good. Excellent. Well done. Very good, everybody. And an example of our magnets, you all know what a magnet is. It's that. It's something that will attract metal. So, for example, if I have some metal and it falls into my food, I could use a magnet to take it out. I could use a magnet to take it out. Okay. Let's have a look at the next one. So the next one, now this one is difficult to say. This one is difficult to say. So listen very carefully. Decantation. Decantation. Listen carefully to me again. Pasa Angrit. Decantation. Nung Song Sam. Very good. Well done, everybody. That's nice to hear. Decantation. Now, what does decantation mean? What does decantation mean? Usually, it means, sometimes I'm sure you've done this. You've tried to separate maybe your favorite drink from something that might have fallen in. Maybe you don't like the bubbles at the bottom and you pour it away and you try and separate it. So here is the liquid, and here's something maybe you don't want in your solution. It's usually something solid is sitting there, and you're pouring away very carefully just the liquid into another container. And that is called decantation. Decantation. The next part is filtration. Filtration. Now listen carefully. Filtration. Filtration. I'd like everybody to say that with me. Filtration. Listen carefully. Filtration. Nung Song Sam.
Filtration.
Filtration. Everybody together, please. Make sure your microphone is on for it. One more time. Nung Song Sam. Very good. Filtration. And this is filtration. This is when we want to separate a mixture of solids and liquids, and we use a piece of paper here to catch all of our solids and let the liquids go through. That is called filtration. It's a piece of paper called filter paper. We have something called a funnel, and then a solid and liquid, and the liquid just comes away by itself. Now we'll talk more about that a little bit later. And the final one, and this one's another difficult word, and I'm sorry about this, precipitation. Precipitation. Listen carefully. Precipitation. Precipitation. Nung Song Sam?
Precipitation.
Okay.
Precipitation.
Very good. What is precipitation? Now this one's a very difficult idea to understand. Basically what it means is that I have something in solution and it's mixed very, very well. I can't see it, so it's a homogeneous solution, usually a homogeneous solution. That means it's mixed very well. I can't see it. So what I need to do is I need to add something into it. I need to add something else into the solution. And what that means is that then the new thing I add combines with the old thing in this solution, and it makes a new mixture. It makes a new compound. So that means if I had, for example, something in this water and I can't see it, but I want to get it out, I add something in there. They come together to make a new compound. The compound then falls down to the bottom and it separates out, and that is precipitation. So let's quick overview. Separation methods. So I have separating solids, hand picking, and sifting. Separating by magnets, and separating solids from liquids. Solids from liquids. Decantation, filtration, precipitation. Now these are all new words and they're new ideas, so I know it's going to be difficult. But we're going to practice now in the next 10 minutes some ideas behind this. So look at this carefully. If I want to separate solids, I can use hand picking and sifting. If I want to separate metals, I can use magnets. If I want to separate a solid from a liquid mixture, I can use decantation, filtration, or precipitation. Okay. So that's enough of me talking. It's been a long talk. That's because it's a big idea and there's lots of things to practice. But for now, everybody please turn in your workbook, turn to page 22. I think it's page 22 in your books. Page 22, Nati Yisepson. And I'd like you all to have a go at question 1. Question 1 only, A to G. Tam Nung A to G. I'd just like you to put tick or cross. So you can put a tick or a cross in the correct answer. So we're going to spend the next 10 minutes just doing this question. So I'm going to read this question to you first, and I'm going to ask you to finish it in your book. A mixture is made up of two or more different substances together. If you think that is true, put a tick. If you think it's not true, put a cross. B, the substance of a mixture is made of liquids only. If you think that's true, put a tick or cross. Now, you can look in your book for this, and there's no rush. We've got the rest of this class to finish this. I'd like you to read through all of that and have a go starting now. Question A, a mixture is made up of two or more different substances together. Is that true? Is a mixture made of two different substances? If you think so, put a tick. If you're not sure, if you don't think so, just put a cross. Question B, the substance of a mixture, the substances of a mixture, that means more than one substance of mixture, are only made of liquids. So basically, are mixtures only liquids? Yes or no? Hand picking, C. Hand picking can be used to separate all type of substances from their mixture. So I can separate anything, liquid, solid, solid liquids, solid solids. I can separate just using hand picking. Is that true? Does that sound true? D. Sand and flour can be separated from each other by hand picking. So, can I separate sand and flour using hand picking? E. We can separate raisins from a mixture of peanuts and raisins by picking the raisins with our hands. So can I separate raisins and peanuts using hand picking? Yes or no? I know which I would say, because I love peanuts and raisins, very delicious. Question F. Sifting is a technique, sifting is a method used to separate solids of different sizes. So I can use sifting to separate solids of different sizes. And question G says, a mixture of sand and stone can be separated by sifting. So if I had big stones and little sand, can I separate by sifting? And whilst you're doing this question, I'm going to show you one more time each example that we have of each one, just to make sure we remember what they are. So remember, this is hand picking. For example, we can separate mixtures using our hand. This is what hand picking is. This is sifting. This is the example of sifting that we used. So we're separating, in this case, big rocks from sand. And magnets. Magnets obviously can separate metal things. Now I'm going to ask you something about magnets in a minute. Okay, so magnets can be used to separate metal. And decantation, remember this is decantation, where we're pouring away liquid from something that is insoluble. And filtration. Filtration is this one. This is where we use a piece of paper, a special piece of paper in a special thing called a funnel to separate the liquid and the solid mixtures. And the liquid comes away and the solid stays here. And we'll talk about the names of those different parts and how they're separated in another lesson. So those are the different methods. And finally, we have precipitation, where I mix another substance to combine with something else in the solution to make it come out, called a precipitate. Okay, before we do that, I'm going to ask the question. A mixture is made up of two or more different substances together. If you say yes, please say yes now. Nern Song Sam. If you say no, please say no now. Nern Song Sam. Ooh, no student is saying anything. Okay, guys, come on. There's no one can tell. I just want to hear your voice say yes or no. Okay? Please say yes if you think A is yes. Nern Song Sam.
Yes.
Well done. Okay, let's have a look, see if you are correct. It is true, yes. If you put a tick or if you wrote true, then give yourself a tick for yourself. That's very good. B, substances of a mixture are only liquids, If you say true, if you think yes, say yes now. Nern Song Sam. If you think no, say no now. Nern Song Sam.
No.
No. No.
Everybody,
No.
okay, I'm hearing lots of no's. Let's see if you're false. That means no. You're absolutely correct. Yes, no. Substances or mixtures can be made of solids and liquids, liquids and solids, solids and gases, gases and liquids, many different things. It can be made of many different substances, many different kinds of matter. Well done. Very good. C, hand-picking can be used to separate all type of substances from their mixtures. If you say yes now. Nern Song Sam. If you think no, please say no now. Nern Song Sam.
No. No. No.
No. Good answer. The answer, of course, is no, false. Cannot be. Because, for example, if we had two different liquid substances, we cannot separate liquids using our hands. It's not possible. We can separate some solids from the liquids, but usually not liquids from liquids. We're not always able to separate solids from solids using our hands. For example, we couldn't separate flour from sand using hand picking. It would be very, very difficult to do that. So the answer is false. D, sand and flour can be separated by oops, I just gave that answer away. D, who says yes? Nern Song Sam. Who says no? Nern Song Sam.
No.
No.
No, you're absolutely
No.
right. We cannot. I think I just gave the answer away anyway. No, we cannot. So that will be false. Cross. No, we cannot. E, we can separate raisins from a mixture of peanuts and raisins by picking the raisins with our hands. If you say yes please. Nern Song Sam. If you say no, please say no please. Nern Song Sam.
No. No. Yes.
No. Who said yes then?
Asim.
Asim. Well, let's have a look. The answer is yes. Of course you can. Yes, you can separate out quite easily. You can separate out raisins, delicious raisins, from peanuts, or you can separate peanuts out from raisins. Always delicious. I do that often because I prefer to eat the raisins. F, sifting. Now remember, sifting is a technique or a method used to separate solids of different sizes. If you say that's true, please say true now. Nern Song Sam.
True.
Good. If you say no, false. If you say no, say no now. Nern Song Sam. Ooh. Well, the answer, of course, is true. Yes. Yes, we can. We can separate solids of different sizes using sifting. Now remember, sifting is when we've got a metal net and we want to separate it out. And the last question for today is, a mixture of sand and stones can be separated by sifting. Separate sifting. If you say yes, please say yes now. Nern Song Sam.
Yes. Yes.
Everybody, please. Thank you.
Yeah.
Okay, and the answer, of course, is yes, it's true. Of course we can. Sifting is designed to do exactly that. Sifting is designed to do exactly that, separate them out. Okay, if you are correct, make sure you give yourself a tick for each one. If you are wrong on this occasion, just write in the correct answer to make sure you're okay. Okay, I think that's it for this morning. I will see you all on Wednesday or Friday. Can't remember.
On Wednesday.
I think Wednesday for math. Oh no, today. I'll see you this afternoon for math. Math this afternoon. Thank you, everybody. See you later. Bye-bye.
Bye. Goodbye.
Bye-bye.
Bye.